Today we're going to talk about intervals. In mathematics, an interval is a section of the real number line. Remember, the real number line is a way to visualize all real numbers. Every real number corresponds to a point on this line. To see this, pick any place and draw a point to mark the number 0. Now, positive numbers lie to the right of 0, and negative numbers lie to the left of 0. To get a sense of scale, pick a place to the right of 0 and draw a point to represent the number 1. Now that you have 2 points, you know how far apart numbers should be spaced out on the line. If this is how far apart 0 and 1 are, then 1 and 2 need to be separated by the same amount, so 2 goes here. Similarly, 2 and 3 are separated by 1, so 3 goes here. We can also go in the negative direction. The integers -1 and 0 are consecutive integers, so they're separated by the same amount as 0 and 1. So -1 goes here. Continuing this process, we can mark -2 and -3. Here are a few of the integers, but every real number has a place on this line. For example, 1/2 is halfway between 0 and 1, so it goes here. The number pi is about 3.14159, so it goes just to the right of 3. The real number -1.75 is smaller than -1 and lies between -1 and -2. It goes here. You could continue this forever, marking off more and more numbers and never run out of numbers. There are an infinite number of points on this line, which is good, because there are an infinite number of real numbers. Now that we've seen how to mark off specific numbers on the real number line, let's talk about how to highlight entire regions of numbers. For our first example, let's see how to draw all the numbers x greater than 1. First, let's pick a point to represent the number 1. In just a moment, you'll understand why I drew a line rather than a point. Now, how many real numbers are greater than 1? There's a lot of them. There's 2, 3, 4. There's also 1.5, 2.5, and 3.5. There's also 1.2, 1.4, 1.6, 1.8. We can keep doing this all day and never run out of numbers greater than 1. There are an infinite number of real numbers greater than 1. So instead of drawing points for the rest of our lives, we just go ahead and highlight the number line to the right of 1 and draw an arrowhead to make it clear that the shading goes on forever. Now here's an important detail. The number 1 is not greater than itself, so we want to make it clear that 1 is not part of the highlighted region. To show this, draw an open circle at 1. An open circle means this number is not part of the shaded region. Next, let's look at all the numbers x greater than or equal to 1. Just like above, we shade the region to the right of 1 to show that these highlighted numbers are all greater than 1. This time, however, we want to include the number 1 because of the greater than or equal to symbol. 1 is equal to 1, so we want to include 1 in the shaded region. To do this, you use a filled circle at the number 1. So you use an open circle when the number is not part of the shaded region, and you use a filled circle when it is. Next, let's flip things around and look at those number x on the real number line that are less than 1. First, pick where you want the number 1 to be and mark it. All the numbers to the left of 1 are smaller than 1, while all the numbers to the right of 1 are larger than 1. So we highlight the region to the left. Like before, since we're using the less than symbol, we do not include 1 itself because 1 is not less than itself. So we draw an open circle at 1 to let people know that 1 is not included in the highlighted region. Here's another example. Let's highlight that part of the number line that covers all numbers x that's less than or equal to -2. Since we want to include -2 in this region, we use a solid circle at the integer -2. These highlighted parts of the real number line are called intervals. Now let's see how to describe regions of the number line that do not go off forever in the positive or negative direction. We'll start by looking at those real numbers that are greater than -2 and also less than 3. First, draw open circles at -2 and 3. We use open circles because we're working with less than signs, so the numbers -2 and 3 are not part of this region. Now, all the numbers greater than -2 lie to the right of -2 on the number line. Remember, as you move from left to right, the numbers are getting bigger and bigger. The numbers less than 3 lie to the left of 3 on the number line, because as you move to the left, the numbers are getting smaller. I'm not drawing on the number line itself because these are more like notes, not the answer. We want those real numbers that are both greater than -2 and less than 3. So we want the overlap between these two regions. So these are the numbers that lie between -2 and 3. So we highlight that part of the number line. It's worth taking a moment and pointing out that this graph and this algebraic expression say the same thing. They both describe an infinite number of real numbers. The interval on the number line is a graphical way to visualize these numbers, and the inequality is an algebraic way to describe these numbers. Let's look at 3 other examples. -2 is less than x is less than or equal to 3. -2 is less than or equal to x is less than 3. And -2 is less than or equal to x is less than or equal to 3. First, we'll draw a number line for each expression. Next, we'll draw open circles for the less than signs and solid disks for the less than or equal to signs. Lastly, we fill in the region between the points on each number line. These are the 4 possible intervals you'll see when you have both a lower bound and an upper bound. The circles are also called endpoints. Even though these intervals don't continue off to the left or right, there are still an infinite number of points in each interval. The real number line is a crowded place. To recap, there are 8 fundamental regions of the real number line you can describe using inequalities. The first 4 are when you have a single bound. The marked number is called an endpoint. When working with less than or greater than symbols, you use an open circle. And when there's a less than or equal to or a greater than or equal to symbol, you use a filled circle. The next 4 regions are when you have an upper bound and a lower bound in your inequality. Each of these highlighted regions is called an interval. And in each interval, there are still an infinite number of numbers, even though there are 2 endpoints. This lesson was brought to you by the Socratica Foundation.